Welcome to this explainer. Step right in, because we are diving straight into the deep end today. I want you to imagine for just a second that the examination hall isn't just a quiet, boring room full of wobbly desks. No, treat it like a high-stakes, fast-paced trading floor. In this kind of environment, time is absolutely your most precious capital. Every single second is an asset, and every single mark you secure is a direct return on your investment. Today, we are focusing purely on maximizing your profit in literally one of the most volatile sectors of the entire Cambridge computer science syllabus. We're talking about Section 9.2 algorithms, specifically understanding the algorithm as a sequence of defined steps. Now, look, too many candidates walk onto this trading floor and they just completely squander their capital. They hit a question, maybe it's a notoriously tricky 9713 past paper question, and they panic buy. We see two distinct types of students making this mistake all the time. First, you have someone like Alex. Alex overloads. The second he sees a prompt, he just starts dumping raw computer science facts onto the page in a chaotic frenzy, offering zero analysis, just hoping something eventually pays out. Then, on the other end of the spectrum, you have someone like Sam. Sam rushes. Sam ignores the command word requirements entirely, sprinting to write code without taking a breath. But here's the reality. Securing top marks isn't about how much raw data you can furiously dump onto the page, and it's definitely not about rushing to the finish line. It is about calculated split-second resource allocation. Every second counts. Every single word you write must earn its keep. By the end of this explainer, you are going to have the exact insider strategy to navigate this pressure cooker, outsmart the traps that catch Alex and Sam, and extract maximum points.
So here's our agenda for today's masterclass. We're covering 1, the missing marks trap, 2, core algorithmic principles, 3, the procedural framework, 4, top 3 examiner warnings, and finally 5, the evaluation masterclass. Let's get straight into it.
Section 1, the missing marks trap. Okay, let's dive into this with a really critical question for you to consider. Seriously, why exactly do students lose easy algorithm marks? We see it year after year, paper after paper. Like we just talked about, you have students like Sam who rush. They spot a familiar keyword, maybe they see the word array, and they just sprint to the finish line, entirely missing the actual specific requirements of the prompt. Or you have students like Alex who go the complete opposite route and over-explain, dumping massive, unreadable paragraphs of raw code and theory, completely ignoring the scenario's context. And the thing is, across Cambridge syllabuses, whether you are looking at the foundations in 0417 or 0478, or jumping into 0983, 0984, 2210, and especially the incredibly rigorous 916 AS and A-level, raw knowledge is practically useless without the correct strategic methodology. Let me say that again because it's that important. Raw knowledge is useless without strategy. You can literally memorize every single sorting algorithm in existence, backwards and forwards, but if you don't answer the specific question sitting right in front of you, the examiner cannot and will not award you the points. Students lose marks because they treat algorithmic questions as a simple test of memory rather than a test of logical, step-by-step application. And this is exactly where we introduce our most powerful weapon on the trading floor. We call it the method mark strategy. I want you to literally make this your mantra every time you sit down for a past paper. The absolutely crucial concept here is that examiners award marks for the step-by-step process and the systematic analysis, not just the final algorithmic output. Think about it like this. If you write a flawless final line of code, but you show absolutely none of your working, no decomposition, no structural planning whatsoever, you are leaving massive, massive profits on the table. The method mark strategy dictates that you document your thinking. You have to explicitly show the examiner how you identify the key elements, how you selected the appropriate data structures, and how you logically mapped out the sequence. Why? Because this ensures that even if you make a minor, silly syntax error at the very end, maybe you miss a bracket or mix up a variable name, you have still banked 80 to 90% of the marks simply by proving your methodology is fundamentally sound. Don't hide your thought process, display it proudly. Moving on to Section 2, core algorithmic principles. I need you to listen very carefully to this exact mandate pulled directly from the Cambridge syllabus. It says, top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. Examiners are actively, constantly searching for this. They do not want a robot who can regurgitate a bubble sort algorithm perfectly from memory. That's what Alex does, and it doesn't work. They want a strategist. They want someone who can look at a completely bizarre, unfamiliar business scenario, let's say an algorithm for managing a fleet of automated delivery drones in varying weather conditions, and instantly transfer their conceptual understanding of algorithms to that brand new context. It is all about causal relationships. How does changing a variable over here completely alter the execution over there? How does this specific concept integrate with other areas of the syllabus? Principal examiner reports state this explicitly.
Candidates who successfully reference cross-topic connections achieve significantly higher marks. That right there is the gold standard you are aiming for.
So when you turn the page and face a massive, intimidating algorithm problem, this is exactly how you must allocate your first 60 seconds. This is where those split-second decisions happen. In the very first 0 to 10 seconds, do not write a single thing. Put the pen down, scan the prompt, and mentally recall the precise definitions and command words. What is it actually asking you to do? Is it asking you to evaluate, to trace, to implement? These command words completely change the game. Then, from 10 to 30 seconds, map the causal relationships. What specific data goes in, and what distinct process is required to get the necessary data out? And finally, from 30 to 60 seconds, identify your cross-topic connections. Does this scenario require extracting data from binary representations? Does it somehow link back to arrays or file handling? If you spend your first 60 seconds executing this mental timeline, you will never panic on the trading floor again. You'll be in complete control.
Now, to put all that brilliant planning into actual high-scoring action, top students structure their written answers using the PEL framework. That stands for point, evidence, explanation, link. First, you make your main algorithmic point. Then, you provide evidence extracted directly from the specific scenario they gave you. Next, you give the explanation of the technical computer science principles behind it. And finally, you link it firmly back to the ultimate requirement of the prompt. By applying PEL, you guarantee that your answers are structurally bulletproof and practically impossible for examiners to ignore. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, Section 3, the procedural framework.
Okay, here are the 4 critical, non-negotiable steps of algorithmic thinking that form your procedural framework. Step 1, deconstruct the question. You have to strip away all the narrative fluff and isolate the exact data points and command words. Step 2, select the appropriate data structure. Ask yourself, is this a job for a 1D array, a linked list, or just a simple loop? Step 3, execute with clear notation. This means efficient code implementation with proper formal terminology, absolutely no vague everyday language here. Step 4, rigorous testing. You must verify your results against the scenario parameters. I want you to mentally apply this sequence right now. Just imagine a question about extracting data from binary representations. First, you deconstruct what the binary actually represents in the context of the question. Next, you select exactly how you will logically store those values. Then, you execute the conversion process clearly on the page. Finally, you rigorously test it with sample inputs to ensure the logic didn't break. This 4-step sequence, it's your safety net.
And this brilliantly illustrates the difference between an amateur and a true exam strategist. Look closely at the comparison here. The generic unsupported claims. This is typical struggling student work. This is our friend Alex, overloading with facts but completely missing the mark. It's covered in red ink. Why? Because writing things like, the algorithm is fast, or it uses a loop earns literally 0 marks. It means nothing. Now look at the clear, context-specific application. This is a perfect, green-checked answer actively using the PEL framework. It says, a for loop is most efficient here. That's the point. Because the system must process exactly 50 student records. There's the evidence from the text. This defined sequence ensures each index in the 1D array is accessed sequentially without an infinite loop risk. Boom, that's the explanation. Fulfilling the prompt's requirement for a robust searching method. And there is the link. Do you see the difference? It is night and day. It is a clear, context-specific application of principles.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome back. Let's look at Section 4, Top 3 Examiner Warnings.
Now we are getting into the real interactive workshop part of this explainer. We've dug through the principal examiner reports, and here are the top 3 fatal mistakes that will tank your grade. First, using the wrong formula or algorithm for the context. This happens all the time when a candidate panics and applies a highly complex sorting algorithm to a tiny dataset that honestly just needed a simple linear search. You waste time and you show a lack of conceptual understanding. Second, missing boundary conditions and edge cases. Listen to me, this is incredibly dangerous. During your rigorous testing phase, if you forget to check what happens at the absolute upper limit, the absolute lower limit, or with an unexpected input, like a negative number when it asks for an age, or a null value, your algorithm crashes. Examiners will penalize you heavily for leaving system crashing vulnerabilities in your code. Third, providing generic answers not linked to the scenario. We've already talked about this, but it bears repeating because it is literally the most common error across all 9618 papers.
Okay, let's test your reflexes. We're going to do a 60-second interactive challenge. I'm putting an imaginary timer on the clock right now. I want you to quickly scan this concept. A student is asked to write an algorithm to monitor temperature sensors in an automated greenhouse. Their written evaluation reads like this. The algorithm uses a while loop to check the temperature continuously. This is good because while loops are effective for condition-controlled iteration. It stops when it gets too hot. Time is ticking. Which sentence in that paragraph is completely bleeding marks? Is it the first one, the second, the third? Look really closely at the lack of specifics. Look at how vague it becomes at the very end. Keep scanning. Have you spotted the flaw?
Time's up. Did you catch it? The fatal flaw was that final sentence. It stops when it gets too hot. That is completely 100% generic. The absolute biggest trap in 9.2 algorithms is failing to apply your knowledge to the highly specific context of the prompt. The principal examiner reports literally scream this from the rooftops. Always link every single point to the given scenario. A top-tier grade A response would have stated, the loop terminates when the sensor value exceeds the boundary condition of 35 degrees Celsius, triggering the cooling system function. See the difference? Context is absolutely everything. Without context, your algorithm is just floating in a vacuum, and your grade is going to sink fast.
Finally, Section 5, the Evaluation Masterclass. Now we're moving to the highest tier skill required for top marks, critical analysis. Top-scoring candidates analyze trade-offs, and they use this exact matrix to do it. You need to be able to critically evaluate time complexity versus space complexity. Time complexity is all about execution speed. How fast does your sequence of defined steps actually run? It determines the overall efficiency of the program. But you must weigh that against space complexity. How much memory usage does your algorithm demand? This sets the hard resource limits. Often in computer science, making an algorithm faster requires significantly more memory, and saving memory makes it run slower. You have to explicitly explain this trade-off to the examiner based on the strict constraints of the scenario. And always, always bracket your analysis with a discussion of edge cases, those critical boundary conditions that prevent system crashes. Mastering this matrix proves to the examiner that you think like a real-world software engineer, not just a student trying to pass the test.
So, the crucial point here is exactly how you structure this evaluation on the page. When a command word explicitly asks you to compare and evaluate, there are strict, non-negotiable comparative analysis requirements. You must identify similarities and differences. Do not, I repeat, do not just list the features of algorithm A in one paragraph and then list the features of algorithm B in the next. That's not a comparison. You must actively intertwine them using comparative connectives, words like whereas, conversely, or in contrast to. You must support every single comparison with hard evidence from the given data. And finally, you must draw definitive conclusions about their relative importance. Don't leave the examiner guessing. Tell them exactly which algorithm is superior for this specific task and precisely why. This analytical blueprint is how you absolutely guarantee high-level marks.
Okay, let's recap everything into the ultimate computer science success blueprint. To dominate the 9618 algorithm questions or any Cambridge CS syllabus, you must follow these 3 rules. First, command word decoding. Know exactly what the examiner is asking before you write a single word. Second, Peel framework application. Structure your process clearly, providing evidence and linking it to the context so you get those method marks. Third, the time management matrix. Evaluate your solutions based on time, space, and boundary conditions. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. So I have one last question for you before we wrap up this explainer. What is your target grade in computer science? And more importantly, what is your biggest challenge right now? Is it memorizing the syntax, or is it applying it to the weird scenarios they give you? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. You now have the tools, the blueprint, and the mindset of a top-tier candidate. The trading floor is yours to conquer. Keep analyzing, test those edge cases, and elevate your methodology. See you next time.